Hello everyone, welcome to our video. Today we'll be learning about Free Space Optical Communication System, which can be also abbreviated as FSO Communication System. So moving on. There are various types of communication system. Some of them are follows: digital communication, wireless communication, satellite communication, optical fiber communication, radio communication, free space optical communication. Now, let's define free space optical communication. Free space optical communication is a wireless communication system. It uses laser to transmit the data from one point to another through the free space. It is capable of to transfer up to 2.5 gigabits per second of data, voice and video communications through the air, operating between the 780 to 1600 nanometer wavelengths bands. Now let us see the working of the free space optical communication system. The components and the block diagram for the free space optical communication system is as shown here. Basically, it consists of the transmitter, channel, and receiver. So let's look into the transmitter part. In the transmitter, what we have is the information signal, or the message signal to be transmitted, which is converted to the digital signal. Then we have a lasers as optical source, which is mainly to provide light as a carrier signal. Along with that, optical source will also convert the electrical signals into optical form. It will also perform modulation, and generally in the optical communication system, intensity modulation is preferred. Thus we have the intensity modulator. As per the information signal, the intensity of the optical source is varied by performing the intensity modulation. For instance, in the digital signal, the message is represented as either 1 or 0, so, corresponding to 0 the intensity is minimized, or the optical source is turned off. And corresponding to the 1 the intensity can be maximized, or consider the optical source as on. Then we have the transmitter aperture, through which the modulated signal is transmitted through the channel, which is free space or atmosphere. On the receiver side, there is a receiver antenna consisting of a receiver aperture. Generally, the receiver aperture size is larger compared to the transmission aperture. Similar to the other optical communication system, the receiver part is optical receiver. The optical receiver consists of a photodiode or photodetector. The photodiode will detect the received optical signal, and it will convert the incident optical power into the corresponding electrical form, that is photocurrent. The photocurrent will be used for further electronic processing, which includes the use of a filter, equalizer, demodulator, converter, and decoder. One of the most important things is that the transmission aperture must be properly aligned with the receiver aperture, so that the light intensity after propagating through the free space can be captured by the photodiode directly. Therefore, free space optical communication system is preferably a line-of-sight communication. In order to ensure the alignment, a system known as positioning and tracking is used at transmitter as well as receiver side. The performance of the FSO system will degrade with the unalignment of the transmitter and receiver. Now we are going to compare the optical fiber communication system and free space optical communication. Fiber optic cable and FSO share some similarities. In both the system, there is use of laser. However, the simple difference is that optical fiber is not used in the FSO communication system. Instead, the signal is sent through air or free space from the source to the destination. Light travels through air faster than it does through glass. So one may regard FSO as optical communications at the speed of light. The installation of the optical fiber communication system is difficult and time-consuming, whereas the installation of the free space optical is easy and fast. The cost for the establishment of the optical fiber is expensive compared to the free space optical communication system. In terms of the fiber optical communication system, it is immobile after it has been once installed, whereas FSO communication system is mobile with reconfiguration. Data transferred through the optical fiber is more secure compared to the FSO. The data transmission in the optical fiber is 100 Mbps to 100 Gbps. Whereas the transmission in the FSO varies based on the application. Now regarding the pros and cons. Let's look into the pros. 1. High data transfer rates. It can achieve very high data transfer rates, often in the range of gigabits per second, or even higher. This makes it suitable for applications that require higher speed data transmission. 2. Low latency. It offers latency, making it suitable for applications where real-time data transfer is crucial, such as financial transactions, video conferencing, and gaming. 3. Immunity to electromagnetic interference. Since FSO relies on optical signals and does not use radio frequency waves, it is immune to EMI, making it ideal for environments with high EMS or radio frequency interference. 4. Secure communication. FSO is inherently secure because the narrow optional beam is difficult to intercept without detection. This makes it suitable for applications where data security is a top priority. 5. No spectrum licensing required. Unlike some RF band communication technologies that require spectrum licensing, FSO does not require such licensing, potentially reducing operational cost. 6. Ease of deployment. FSO systems are relatively easy to install and can be quickly deployed for point-to-point communication links, especially in scenarios where laying physical cables is impractical or expensive. Then looking into the cons. 1. Line of sight requirement. FSO communication requires a clean line of sight between the transmitter and receiver. Obstacles, such as buildings, trees, or even atmospheric conditions like fog and rain, can disrupt the optical beam, limiting its range and reliability. 2. Atmospheric interferences. Weather conditions, including snow and atmospheric turbulence, can attenuate or scatter the optical signal, leading to signal degradation and reduced link availability. 3. Limited range. FSO system is generally limited to relatively short to medium range links, typically up to a few km, due to the limitations imposed by atmospheric conditions and curvature of the Earth. 4. Susceptibility to pointing errors. Accurate alignment and tracking between the transmitter and receiver are critical for FSO communication. Even slight pointing errors can result in signal loss or degradation. 5. Limited multicast and broadcast capabilities. FSO communication is primarily on point-to-point technology, making it less suitable for applications that require multicast or broadcast capabilities over a wide area. Moving into the application of the FSO. There are lots of application of the FSO. Some of the applications mentioned below are disaster recovery and emergency communication. FSO can be rapidly deployed to establish communication links in disaster-stricken areas where other communication infrastructure is damaged or unavailable. It is particularly valuable for first responders and relief organizations. Smart cities. FSO can be part of smart city infrastructure, enabling high-speed data links for various applications such as traffic monitoring, environmental sensing, and public Wi-Fi access points. Transportation. FSO can be used in transportation systems to provide high-speed data links for autonomous vehicles, trains, and drones. It can enhance communication for traffic management, vehicle-to-vehicle communication, and more. Aerospace and satellite communication. FSO can provide high-speed, high-bandwidth communication links between spacecraft, satellites, and ground stations, enabling data transmission, remote sensing, and telemetry. Military and defense. FSO can be used for secure and high-bandwidth communication in military applications. It's less susceptible to interception or jamming than traditional RF communication. It's also used for secure point-to-point links between military installations. So this is the end of the video. Thank you for watching the video.